Hello and welcome back to Math Class in Session. Special angles to determine exact values. Some angles are very special, just like some of the students at the high school that I teach in. 30, 60, and 45 are special angles, and let's find out why. We begin with an equilateral triangle with sides of length 2 units, and then draw the altitude from vertex A. So we could build one of these equilateral triangles of any size. So let's build one of side length 2 units, 2 on every side and 60 degrees in every angle. Drop an altitude from vertex A, and now it looks like this. You see, this altitude from vertex A splits the triangle in two. So this 2 will become 1, and this 60 will become 30 and 30. And so now it would look like this. 30 degrees here and just 1 here because this side got split in half. Consider this bold triangle. Using Pythagoras, we can determine side AD. Now side AD will be the square root of 2 squared minus 1 squared. Simple math here. AD squared is 2 squared minus 1 squared. So AD equals root 3. Now if we look at the bold triangle, we have what's called a special triangle. And it looks like this. It's a special triangle because it gives us the exact trig ratios for 30 degrees and 60 degrees, exact trig ratios without a calculator. Sine of 60 using SOHCAHTOA, opposite over hypotenuse, root 3 over 2. Cos of 60, there's our argument, adjacent over hypotenuse, 1 over 2. Tangent of 60, opposite over adjacent, root 3 over 1. We could just call that root 3. Same thing with the sine. Sine of 30, there's our argument, SOHCAHTOA, opposite over hypotenuse, so 1 over 2. Focusing on our argument, cosine, adjacent over hypotenuse, root 3 over 2. Tangent 30, SOHCAHTOA, opposite over adjacent, so 1 over root 3. And what's necessary for a student is that a student learns this special triangle and memorizes it. I like to say opposite the 30 is the 1, the hypotenuse is 2, and the other side is root 3. It's good to say opposite the 30 is the 1 because this triangle can be oriented in so many different ways. It can be flipped upside down, twisted sideways, rotated a little bit. You can lose your bearings, so if you just remember opposite the 30 is the 1, you'll usually get it right. Moving on, let's see if we can do the same thing for a 45-degree angle. Consider an isosceles right triangle. Isosceles means two sides are the same. Right triangle means that there's a right angle in it. Each of the smaller angles must be 45 degrees because they have to be equal to each other and they have to add up to 90 to make 180 degrees with this 90 degrees here. We could give each of the shorter sides a length of 1. We could give them any length we wanted. Let's give them a length of 1 unit. Using Pythagoras to determine the length of AB. Well, it's pretty simple. AB squared equals 1 squared plus 1 squared. Doing the math, AB must be root 2. And now we have another special triangle, which is going to provide for us the exact trig ratios of 45 degrees. Sine of 45 using SOHCAHTOA, opposite over hypotenuse. Cosine 45, adjacent over hypotenuse. And tangent 45, opposite over adjacent, which is 1 over 1. Let's call that 1. And so a student's task is to memorize these two triangles, because from these triangles we can get the exact trig ratios of the special angles. Let's do some examples. Now I've put the special triangles on the side here so we can reference them. You'll run into questions where it says evaluate the expression exactly. Example here, sine 60 sine 45 minus cos 60 cos 30. And you have to evaluate it exactly. What one does is references these two triangles to get the exact sine 60. That means exact means you didn't use a calculator. So sine of 60, there it is. Focusing on that with SOHCAHTOA, opposite over hypotenuse. So this sine 60 becomes root 3 over 2. And in a similar way, each of these are achieved by referencing the special triangles. So this is root 3 over 2 times 1 over root 2 sine 45. Subtract cos of 60, referencing this one, 1/2 times cos of 30. There's 30, the cosine, adjacent over hypotenuse, root 3 over 2. And there it is. There's the expression evaluated exactly, but it does need to be tidied up. So, multiplying the fractions together, top times top over bottom times bottom, of course, and rationalizing this denominator right here, so top and bottom of this fraction only times the radical only, so it will become multiplying top and bottom by root 2. It becomes root 6 over 2 times root 4, and root 4 is 2, so 2 times 2 is this 4 right here, which came from root 2 times root 2 is 2, and 2 times 2 is 4. Notice how it's now rational on the denominator, and by some coincidence we already have a common denominator, so subtracting the fractions is easy. A final one, cosecant 60 secant 45 cos 30 minus cotangent squared 45 secant squared 60 cotangent 60. Special triangles available to us. Let's begin. Cosecant 60, referencing 60, thinking cosecant, which is an upside down sign, so it won't be root 3 over 2, it will be 2 over root 3, and so on. So the cosecant 60 is 2 over root 3. The secant 45, which is a cosine, upside down, so it won't be 1 over root 2, it will be root 2 over 1. Cos of 30, referencing 30, cosine adjacent over hypotenuse, so root 3 over 2. Subtract cotangent squared 45, referencing 45. Cotangent is a tangent upside down, so it won't be this one over this one, it will be that, the reciprocal of that, which is the same. It's still 1 over 1. Squared. Secant squared of 60. So a secant is the reciprocal of the cosine. So we'll take the cosine of 60, which is 1 over 2, and flip it over 2 over 1, and square it, because this says secant squared. And the cotangent of 60. It's a tangent, inverted. So the tangent of 60 is root 3 over 1, so flip that upside down, 1 over root 3. And through some labor, and through some knowledge of special triangles, we've turned a complicated-looking expression into at least a bunch of numbers with algebra. In this case, again, we have two terms, a large term here, subtract another term here. So we have to simplify the two terms. They're fractions, so it will be top times top times top over bottom times bottom times bottom. So this will be 2 root 6 over 2 root 3. Subtract top times top all the way across. So 1 squared is 1, 2 squared is 4, 1 times 4 is 4, times 1 is this 4 right here. And across the bottom, 1 squared is 1, times 1 squared is 1, this is 1 times 1, times root 3. That's where that came from. These 2's will cancel out of that term. Factor off the top and a factor off the bottom in a single term. Leaving this behind, and let's see here. We've already got a common denominator, so we can simply subtract these fractions. And it's common to rationalize the denominator. If you see a radical in the bottom, Many people will rationalize that denominator by multiplying top and bottom by that radical. And you can see what happens. This becomes root 9. And on the top, it will be root 18 minus 4 root 3 when you multiply this across the top here, using our knowledge of multiplying radicals. Now, root 9 is the number 3, and that's rational. And that's why we did this little exercise. And root 18 breaks down, as we know, from a previous unit in math. It's root 9 root 2, because 9 times 2 is 18, and root 9 is a number that we know. And so this is the simplified version of this more complicated expression.